Okay, which one do you want to do first?
Let's do the square root of 2 being irrational.
Alright, square root of 2 is irrational. Do you know how to prove this?
Sort of, yeah.
Do you?
I think so, maybe.
Yeah, alright.
Alright, well why don't you guys give it a try together?
Alright, so
So,
you say,
Which
you
is-
assume it is rational.
so square root of 2 is rational, which means that it will equal a over b, where a and b are integers and they can't be simplified further.
Okay, so that's what it means to be a rational number, right? That you
Yeah.
can write it as a ratio of two integers.
Yeah.
So that is the definition of a rational number. And the idea that it can't be simplified is,
So
Well, just that you
it's-
simplify this
You simplify this to the point where they're
relatively prime to each other.
relatively prime.
good, okay, good start.
So you could start by squaring everything.
Okay, why does that seem like a good idea?
Because
This
this, the square root is kind of annoying and we don't know how to deal with it.
Yeah.
So just square it.
Uh-huh.
So 2 equals a squared over b squared.
Okay, so it seems like a good way to start because the only thing we know about the square root of 2 is that when you square it,
This happens.
you get 2.
So then maybe we can
multiply by b and
yeah.
get rid of the fraction.
b squared or 2b squared equals a squared.
Okay.
Well, here, I guess, we know that a squared has to have a 2 in it. And since a squared is an integer, we know that a has to have a 2 in it.
Alright.
Which means that b shouldn't have a 2 in it.
Alright, we'll
so-
work through that math.
A is even.
A is even. Okay, we know A is even because this side is even. And this side then, since they're equal, has to be even.
Even, yeah.
Even numbers squared are even, odd numbers squared are odd. So
Yeah.
we know A has to be even, okay?
So that means b should be odd, otherwise you could simplify it further.
Right, so if A is even, B has to be odd.
Yeah.
Very good.
So I guess we could say that, I'll go with x equals, or 2x equals a.
Alright, 2x equals A. Good.
So then we can say that 2b squared equals 4x squared.
Okay.
So you
know that-
divide.
B squared equals 2x squared. Now we have the same thing we had here, where b has to be even now.
Alright.
Because we have an
and
x
then-
squared on this.
So that means you could divide the fraction by 2 on both
So
top and
both
bottom.
a and b are even.
That means you could simplify it, but we had it simplified to the highest. We had it simplified down to where they were relatively prime before.
Okay.
So now
And then we can just do this over and over, and eventually we can see that it'll never become
we
rational.
just plug this back in. I'll keep doing this forever.
Yeah, and you were right to call this the descent argument. So basically what we said is they started out in lowest terms and we found out that they couldn't be in lowest terms.
Yeah.
So that was a contradiction. And so we knew our assumption that we could write this in as rational as integers, fractions in lowest terms was wrong,
So
which
that
means it
means-
can't be written that way.
It's irrational.
So therefore it is irrational.
Yeah.
Okay, very good. Awesome. Good work. All right, let's talk about the integers being countable now.